them. It doesn't matter what color you use. And what we're going to do is we are going to find out which values, which angles that you can do on the unit circle without the use of your calculator. And these will be expected of you to be able to do mental math with going forward. So what we're doing here is we're starting off with the axes family. On the unit circle, the axes family means the points on the unit circle where the axis hits the unit circle. And what we're going to do for each of these points is label the angle in degrees, the angle in radians, what the actual coordinates are, and what tangent of each of those angles is. So on the axes family, and I'll start with degrees, and what we're also going to do is we're going to try to position where we put each of our labels in the same place every time. So I'm going to put degrees right here. This is 0 degrees or 360 degrees if you went all the way around. This would be 90 degrees, 180 degrees, and 270 degrees. In radians, this is 0 and 2 pi. 180 was pi. 90 then is half of pi, pi over 2. And 270 is 3 pi over 2. So far, labeling our angles should have been fairly straightforward for the axes family. Almost no thinking required. Now, labeling your points is easy as well because on a unit circle, the radius is 1. So if I go 1 to the right, does it make sense that this point is at 1, 0? If I went 1 up from the origin, I would be at 0, 1. 1 to the left, negative 1, 0, and 1 down, 0, negative 1. And this just opens up some mental math that maybe or maybe not you could do before. For example, I can now tell what is sine of 90 degrees without a calculator. How can I tell from this picture what sine of 90 degrees is? Well, the coordinates on the unit circle, our big idea was the coordinates are cos theta, comma sine theta. So the y coordinate is always what sine of theta is. If the y coordinate at 90 degrees is 1, that tells us sine of 90 degrees is 1. Cos of 180 degrees would be x coordinate, negative 1. Cos of 270 degrees, 0. Sine of pi over 2 would be 1. Cos of 2 pi would be 1. So we can now use this picture to do all the mental math for sine and cosine for each of those angles. And since tangent is sine theta over cos theta, we can also write that tan of 0 will equal 0. And tan of pi will equal 0. But when I go to tan of pi over 2, I get the sine is 1, the cos is 0, this is undefined. Because you're not allowed to divide by 0. And the same thing's going to happen down here at 3 pi over 2. Tan of 3 pi over 2 is also impossible because if the big idea for tan is that tan is always sine theta divided by cos theta, and the cos theta is 0 because it's the x coordinate, then that will always be undefined. So knowing the big ideas and knowing how to label points, we now can do mental math for all of the angles that are on the axis family. And you'll be expected to, from memory, if someone said, hey, what is tan of pi? You'd have to know that that's 0. And you'd have to know negative angles too. What is sine of negative pi? So sine of negative pi, think, okay, in standard position, negative pi would end at this point right here. Sine is my y-coordinate. So sine of negative pi would be 0. Our second family is the 45-degree family. And in order to do the 45-degree family, you're going to need to draw, and I'm going to give some space in the bottom corner, a special triangle for 45 degrees or pi over 4. So in the 45-degree family, we are looking for these coordinates. And in order to find those coordinates, we need sine theta, cos theta, and tan theta for 45 degrees. So we go back to our grade 10 math, and we say, well, I can get sine, cos, and tan if I have a right angled triangle. So my special triangle for 45 degrees, I'm going to draw a right angled triangle, and I'm going to make sure one of the angles is 45 degrees. Now, if you know 2 angles in a triangle, you can find the third angle in a triangle, and it just so happens that when you make one angle 45 degrees, the other angle has to be 45 degrees as well. Which makes this a special kind of triangle. It's a right angle triangle, that's special already, but what do you call a triangle when the 2 angles are the same? Do you remember the name of it? Starts with an I. Isosceles. This is an isosceles triangle. Isosceles triangles not only have 2 angles the same, but they have 2 sides then that are the same as well. And the idea of trigonometry is sine of 45, cos of 45, tan of 45 is true no matter how big or how small your triangle is. So I can pick any number I want for this side. I can pick 1, 2, 3, 4. Whatever number I pick for this side, if I pick 1, you would know this side also has to be 1. And if you know 2 sides of a triangle, you can do a squared plus b squared equals c squared, and find out this side has to be the square root of 2. From this triangle now, I can write that sine of 45 degrees is opposite side 1 over root 2. And you'll see sometimes people will write sine of 45 as 1 over root 2, and sometimes they will rationalize the denominator. Remember this from grade 11? And write it as root 2 over 2. In grade 12, you could write the answer either way, 1 over root 2 or root 2 over 2. When you took grade 11 math, they never let you keep a square root on the bottom of a fraction. It was considered unsimplified. I will write it in the simplified form, the root 2 over 2 form, because if you get a multiple choice question, it would always be in the simplified form. However, you could leave your answer as 1 over root 2. In grade 12, they don't take off a half mark for that because they assume you know how to rationalize the denominator and put it in simplest form if you wanted to. So they're cutting you a little slack in grade 12. Similarly, I could find cos of 45 degrees. It is also adjacent over hypotenuse, which will be the same answer, so I'm just going to write root 2 over 2 again. And tan of 45 degrees, opposite over adjacent, well, that's just going to be 1. That special triangle is going to help us in labeling this triangle. But first of all, we'll start with degrees. To be part of the 45-degree family for the unit circle, every single angle has a reference angle of 45 degrees. So this first angle, starting from here to here, that would be 45 degrees. This angle in quadrant 2 would be 180 minus 45 degrees, 135 degrees. And in quadrant 3, you would go 180 plus your reference angle of 45 degrees to get 225 degrees. And finally, in quadrant 4, you would go all the way around 360 degrees, subtract your reference angle of 45 degrees, and get 315 degrees. We'll do the same thing in radians. 45 degrees is pi over 4. You can figure that out because pi radians is 180 degrees. And 180 divided by 4 makes 45. So you would have to take pi and divide it by 4. So to figure that out. Now, at 135 degrees, you could either change 135 degrees to radians by multiplying by pi over 180. However, I think it's going to be easier if we think the same way we thought in degrees. The angle in quadrant 2 right here is going to be halfway around as pi radians. Subtract your reference angle of pi over 4 radians. How do we do that? How do we do the math of 180 minus 45 was easy because those numbers work. But here we have pi minus pi over 4. How do you subtract fractions? You need a common denominator. Does it make sense that I can change pi to 4 pi over 4? And then 4 pi over 4 minus 1 pi over 4, that will leave me with 3 pi over 4. You're going to have to get really good at adding fractions. Adding fractions with pi. Can you figure out what the next one's going to be? We would have to go halfway around, which is pi, plus pi over 4. So this is just going to change to a plus sign. Does it make sense that it will become 5 pi over 4? And similarly, in quadrant 4, to find the radians, you'd have to go all the way around, which is 2 pi, and then have to subtract pi over 4. And another thing that you're going to get really good at for fractions is changing 2 pi to any denominator you want. So if I want to change 2 pi to have a denominator of 4, what would have to be on the top? 8 pi. Perfect. And 8 pi minus 1 pi would leave me with 7 pi over 4. We've labeled our degrees. We've labeled our radians. Next, we're going to go to our coordinates, and our coordinates are based on our big idea. Our coordinates say your x-coordinate is always cos of theta. And we have from our special triangle that cos of 45 degrees is root 2 over 2. So our x-coordinate is the square root of 2 over 2. Our y-coordinate is always sine of theta. And so from here, from our special triangle, we would know that sine of theta is also root 2 over 2. Now, I'm not going to get you to write this down, but one of the amazing things about reference angles and the unit circles, so don't draw this in, but I'm going to make a triangle here, And I want you to realize that that is exactly the same triangle as this one, exactly the same triangle as this one, and exactly the same triangle as that one. Those triangles are all identical. In other words, does it make sense that the height of this point over here is exactly the same height as that point over there? And the length is going to be exactly the same as well, except this time, instead of going root 2 over 2 to the right, I'm going to go root 2 over 2 to the left. So if all of those values are the same, does it make sense that now my x-coordinate would be negative, but my y-coordinate would still be positive? And in quadrant 3, my x-coordinate would be negative, because I'm going to the left, and I'm going down, so my y-coordinate will be negative. And in quadrant 4, I'm going to the right, so my x-coordinate is positive, and I'm going down, so my y-coordinate is negative. Now the positives and negatives should make complete sense because you're going left and up or left and down. Based on which quadrants they're in, your y-coordinates have to be negative in quadrants 3 and 4. Your x-coordinates have to be negative in quadrants 2 and 3. But the crazy thing that just happened that you might not have noticed is that your unit circle just explained your cast rule. The cast rule that you've learned for so many years, well, just the last couple of years. It's only me that has known it for so many years. The cast rule, which says where things are positive, can now be explained by the big idea of the unit circle. Like your x-coordinate is cos, your y-coordinate is sine. They're both positive in quadrant 1. Which one's negative in quadrant 2? Your x-coordinate's negative. Cos is negative. Sine is positive. And we're going to see that the cast rule for tan gets explained as well because, here we'll write them in, tan of 45 degrees, well that we can get right from our special triangle, it's equal to 1. You can also get it by doing sine divided by cos because they're both root 2 over 2, root 2 over 2. Divide them, you would get 1. When you get to quadrant 2, tan of 3 pi over 4 is going to equal negative 1. Because now what my x-coordinate's negative divided and my y-coordinate is positive. And when I do sine divided by cos, I'm going to get a negative. But I also can see that from quadrant 2, in my cast rule, tan should be negative as well. Look at quadrant 3. Both sine theta and cos theta are negative, and that makes tan theta positive. And finally, in quadrant 4, it's negative again. Okay, we're going to pick some volunteers here. Haley, you got to pick the first volunteer. You don't have to go first. And the first volunteer is going to have to say, what is cos of 135 degrees? Who are you going to pick? And once you've been picked, you can't be picked again until everybody's been picked once. Who's going first? Cos of 135 degrees. Not two. What is cos of 135 degrees? So the answers are on here, but not directly, right? Because we're going to use our big idea from our coordinates. Our coordinates tell us that the x-coordinate is always cos of theta, and we're doing 135 degrees, and our y-coordinate is always sine of theta. So when I say, what is cos of 135 degrees, what do you think? So we would go on our unit circle, we would find 135 degrees, then we would look at our coordinates, and which coordinate is cos? The x. So cos of 135 degrees is negative root 2 over 2. You gotta pick the next person. Who is going to do sine of 225 degrees? Andre. Or did you mean Linda? Andre. Which one did I say? Cos of 225 degrees? Sine of 225 degrees.
Minus square root of 2 divided by 2.
Yes. Minus the square root of 2 divided by 2. You look at the y coordinate at 225 degrees. Next one, we will do negative 45 degrees. And we will do cos of negative 45 degrees. Andre, who are you going to pick? Linda.
Well, if it's negative, it would be going down,
Right. So we,
So
in standard position, negative 45 degrees would be coterminal with 315 degrees.
yeah, so, and would it be, what was the,
Cos. Cos of negative 45 degrees.
so if I'm trying to find cos, am I trying to find the positive?
Well, if you're trying to find cos, you're thinking about your big idea. Cos is the x coordinate.
Okay.
So is the x coordinate positive or negative? At negative 45 degrees, right here, it's positive root 2 over 2.
So it would be cos,
Cos of negative 45 degrees
oh, okay, cos of negative 45 degrees, square root 2 over 2.
is equal to square root of 2 over 2. Perfect. Okay? Now we get to our last two families, and our last two families we can do with one special triangle. So maybe right in between here. And the reason there's a special triangle that's both for 30 degrees and 60 degrees is because if I make a right angle triangle and I label one angle as 60 degrees, the other one has to add up to 180, making this 30 degrees. Yes. Inside the brackets is pi over 6 and pi over 3. Just like they're up here, pi over 6 family with 30 and pi over 3 family with 60. Here's a question for you. You remembered when I gave you the hint that if two angles are the same and two sides are the same, that kind of triangle, when I said it started with the letter I, was isosceles. Do you remember the name for a triangle where all three angles are different? And the hint is it starts with an S. Look at that. You guys are doing so good. This is why this triangle feels kind of bad, sad. Nobody remembers its name. It's called a scalene triangle. And the part of the reason nobody remembers what a scalene triangle name is because it has actually no special properties. Like isosceles, like, ooh, we got two sides that are the same, right? What's another kind of triangle that you've learned? Equilateral, like, oh yeah, those ones are like, all of our angles are the same, all of our sides are the same. Those ones feel really good when they're walking down the street. But poor scalene triangle, they're just all different. And so they're kind of shy and people don't talk about them very much. And so here's our little scalene triangle, and it's not feeling very special at all, and it's kind of sort of walking down the street slowly. And it runs into another identical scalene triangle, and they're kind of like, hi, hi, and they like, they start to get along because they have a lot in common, and they're like, And they're like, so they like get together. And so if I draw this exact same triangle again on the other side, with 90 degrees here, 60 degrees here, and 30 degrees here, these two triangles, these two scalene triangles get together and something special happens. What kind of triangle did it make when you put them all together? It made an equilateral triangle, which means that not only on that big triangle are all of the angles the same, it also means all of the sides are the same. And with trigonometry, it doesn't matter what number you put. We could put all the sides as 5, all the sides as 10. For simplicity, I'm going to choose 2. And the reason I'm not going to choose 2, because you see this whole bottom length has to be 2, but it's cut nicely in half. So this side has to be 1, and this side has to be 1. And all of a sudden we have 2 sides of a right angle triangle. We can do a squared plus b squared equals c squared. So 4 minus 1 is 3, so this side will be the square root of 3. And we have the special triangle and all of its sides labeled. If we have all of its sides labeled, we are able to write sine of 30 degrees, cos of 30 degrees, and tan of 30 degrees. Sine, opposite over hypotenuse, 1/2. Cosine, adjacent over hypotenuse, root 3 over 2. Tan, opposite over adjacent, 1 over root 3. And again, we could rationalize this. So sometimes you will see it written as 1 over root 3, and sometimes you will see it written as root 3 over 3. And we can also, from our triangle, get sine of 60 degrees, cos of 60 degrees, and tan of 60 degrees. Now for sine of 60 degrees, it's still opposite, but now my opposite is root 3. Hypotenuse is still 2. Cos, adjacent, now my adjacent is 1. And tangent, my opposite is root 3, my adjacent is 1. And we get root 3 over 1, which is just root 3. So this will set us up to be able to do the pi over 3 family, the pi over 3 family is the 60 degree family, and also the pi over 6 family, which is the 30 degree family. But on this one, I'm going to get you to do a little bit on your own. We're going to move back up here to our pi over 6 family. We're going to label our coordinates that we need to do. We're going to start in degrees, label 30 degrees, and I'm going to get you to label the other 3, knowing that they all have a reference angle of 30 degrees. And you have a 30-second head start. How was 30 seconds? Was it enough to beat me? Did you get 150 degrees, 210 degrees, and 330 degrees? Now, 30-second head start with the radians. Pi over 6. How did the 30 seconds go with radians? Was that enough to finish ahead of me? Did you get 5 pi over 6? Again, you would think about pi minus pi over 6 and get a common denominator to get 5 pi over 6. Then 7 pi over 6 and 11 pi over 6. Coordinates. What will I put as my x coordinate? Will it be 1/2 or root 3 over 2? Root 3 over 2, because your x coordinate is cos. So you look at your special triangle here, you go to cos of 30 degrees, you get root 3 over 2. Your y coordinate is sine. Sine of 30 degrees is 1/2. And you have 30 seconds to fill in the other coordinates. How did you do? Did you get negative root 3 over 2, positive 1/2? Negative root 3 over 2, negative 1/2. And positive root 3 over 2, negative 1/2. And finally, from our special triangle, we know that tan of 30 degrees, or tan of pi over 6, is root 3 over 3. Tan of 5 pi over 6, according to your cast rule, quadrant 2, tan is negative. Tan of 7 pi over 6, well, tan is positive in quadrant 3. And finally, tan of 11 pi over 6, negative again. We get negative root 3 over 3. I think, Linda, you were the last volunteer. You got to pick someone who's going to tell me what sine of 330 degrees is. Who are you going to pick? Someone who hasn't been picked. And Haley is still available, even if she didn't answer a question, but she started it all off. You can just point to someone if you don't know their name. In the back? All right. What is sine of 330 degrees? Perfect. Negative 1 over 2, minus 1/2. Excellent. What is cos of 210 degrees? Who are you going to pick? Lennon. What was cos of 210 degrees?
Negative root 3 over 2.
Perfect. I'm going to make your brain hurt just a little bit on this next one. What is tan? Tan is pretty easy because they just say up there, but I'm going to give you a negative angle. What is tan of negative 7 pi over 6? What is tan of negative 7 pi over 6? Lemon, who are you going to pick?
Blue.
Blue. It is negative root 3 over 3. So let's, first of all, when I say negative 7 pi over 6, you have to figure out where that's going to end. Now, 7 pi over 6 in the positive direction, do you see how that's in quadrant 3? Negative 7 pi over 6 is going to be in the third negative quadrant, which is quadrant 2. So then once he figured out it's in quadrant 2, he just had to look and say, negative 7 pi over 6 is coterminal with 5 pi over 6. So it's going to equal negative root 3 over 3. And he's like, oh, I just sort of guessed. Or maybe he just guessed. He was like, it's either positive root 3 over 3 or negative root 3 over 3. I'm going to go negative just because Mr. JR used a negative angle. But it's not. I could have done negative 5 pi over 6. And negative 5 pi over 6 would be coterminal with 7 pi over 6 in quadrant 3. So tan of negative 5 pi over 6 would be positive root 3 over 3. Oh, yeah, and we get to our last one. I'll give you again. We'll put the dots on the unit circle where these angles are. I'll give you a 30-second head start for 60 degrees. If you get done ahead and you want to start the radians, you can. How did you do? 120 degrees, 240 degrees, and 300 degrees. Now the radians for the pi over 3 found. Okay, how did you do? Did you get 2 pi over 3? 4 pi over 3? And 5 pi over 3? Then from our special triangle, we see that cos of 60 degrees is 1/2, and sine of 60 degrees is root 3 over 2. So finish the rest of your coordinates.
Question with the,
So to get the 5 pi over 3?
Yeah.
So in degrees, you would do 180 minus your reference angle. I mean 360 all the way around, minus your reference angle. So in radians, all the way around is 2 pi, minus your reference angle, which is pi over 3. So then we have to change 2 pi to have the same denominator. So I'd multiply top and bottom by 3. And you get 6 pi over 3 minus 1 pi over 3 would give you 5 pi over 3. So checking your coordinates. Did you get negative 1/2 root 3 over 2? Negative 1/2, negative root 3 over 2. And positive 1/2, negative root 3. And from your special triangle, tan of 60 degrees or tan of pi over 3 is the square root of 3. That makes tan of 2 pi over 3 negative root 3. Tan of 4 pi over 3 positive root 3 again, and tan of 5 pi over 3 negative root 3 again. I don't think we have many volunteers left. What is cos of 5 pi over 3? Blue, who are you going to pick? Sam. Cos of 5 pi over 3. Negative 1 half, or sorry, positive 1 half, yes. Right, because cos is your x coordinate. What is sine of 120 degrees? Who hasn't gone? There's like 1, 2, you haven't gone yet? 3 people haven't gone. 4 people haven't gone yet. Okay, we'll finish up. Okay. Sine of 120 degrees, who are you going to pick? Beta. Root 3 over 2. How about tan of negative 2 pi over 3?
Sorry. Tan over.
Tan of negative 2 pi over 3.
Negative 2 pi. 3. Or square root of 3.
Square root of 3, because it's going to be coterminal with 4 pi over 3. Perfect. What is cos of negative 240 degrees? Haley.
Aren't you lost one?
No. Haley and Zara. So Haley's next. Cos of negative 240 degrees. One half. So negative 240 degrees, this is sometimes the way that I think about it. It's going around in this direction, but if 240 degrees is part of the 60-degree family in quadrant 3, right? If I go back, right, that many, 1, 2, 3, it would be coterminal with 120 degrees. So then cos of negative 240 degrees is going to be your x coordinate here, negative 1 half. And last one, what is sine of, let's go with 4 pi over 3. Negative root 3 over 2. Perfect. What we are going to do with this whole unit circle is the next thing I'm going to hand out is your next quiz. This is the only quiz that you get the quiz handed out to you, but you still have to do it in class. Okay? This is also the only quiz that you are required to get 100% on. Nothing else is acceptable. And what the quiz looks like, give me a second here to find it. This is what your quiz looks like. I have a copy for everyone. And what it is all 4 families that we've done get combined onto this quiz. And you'll notice the one thing that I did first on the quiz is I color-coded my families. Because once you know quadrant 1, you should know all the other, like for example, the pi over 6 family there is in blue. Once you know quadrant 1, you should know all the other 3 quadrants. Because the angles, reference angles, go together. The coordinates are all the same, just changing pluses and minuses. So for your quiz, which is going to be next week, Wednesday, so we can take off. This is done. Your test is tomorrow. The review is done. Our unit circle quiz is next week, Wednesday. And on the unit circle quiz, you have to get 100%. If you make one mistake, you forget a negative, you write coordinates mixed up one place. You fill in the chart at the bottom wrong, one mistake, and you get 0. Now, you have more than one chance. There are lots of people that get 100% with no mistakes whatsoever on the first try, but there are also lots of people that make one little mistake on it the first time. So, you have, after the quiz on Wednesday, if you do not get 100% the first time, you have 1 week and as many chances as you would like in that week to get 100%. If you do not get 100% in 1 week, then it stays at 0. Most people get it after, right? The first time you make a mistake, you're kind of mad at yourself. That kind of heightens your motivation. Most people get it after 2 or 3. There has been times where someone keeps making mistakes 6, 7 times, and like, it's annoying because every time you have to come in at the lunch hour or before school or after school on your own time to write it, it's like, takes a while to do. You're like, I want to get this right. So, we will talk about next week some strategies that can help you memorize it so that by Wednesday of next week, you are ready. We are also going to do a project for the unit circle where we put all of the unit circles onto a paper circular plate. And I'll describe that project on Monday when everybody else is here. But for right now, you can take the time to start filling out the information from your 4 families onto the unit circle. On the back side is a blank one. That's one for you to practice to see if you can fill it in from memory afterwards.